The Linux shell packs a lot of power. Its standardized input and output allow you to chain commands together in intricate yet easy ways. Take a file, ditch the header, extract the fields, replace in bulk, sort, filter to unique values. It really is a digital Swiss Army knife. It only makes sense that you want to repeat common recipes, throw in some classic programming staples for even more flexibility, and boom, you've got shell scripts. You can use them on anything that runs Linux, including servers, desktops, and Raspberry Pis. They will also run on Macs. Even Windows, yes, that Windows, came around and now supports it. But as powerful and universal as shell scripts are, once you start doing anything that's slightly more advanced, things get a little weird. Hi, I'm Peter, and today we're diving into the quirks of shell scripts. Suppose you're trying to download files in bulk, and the URLs of those files are all in an index file. Watch what happens. The initial download fails, but the script continues. More often than not, it's a good idea to halt programs immediately as soon as they run into a snag. Bash supports this behavior, but scripts don't do it by default. If you add set-e at the top of your script, execution will stop immediately whenever a command runs into an error. Now you've minimized the damage bugs can do in your script, and you've made it easier to find them. See if you can figure out why the following script's acting strange. By default, Bash treats undefined variables as empty strings. This causes line 6 to resolve to SSH at 192.168.1.40. Obviously, this can backfire very easily, but luckily, you can get rid of this quirk by putting set-u at the top of your script or combine it with set-e like I did. Now the command line will produce an actual clear error message when you're trying to use a variable that doesn't exist. Okay, new challenge. If you want to find the bug before I tell you where it is, pause the video now. Remember when we told Bash to terminate the script if a command has a non-zero exit code? Well, there's still a loophole when you use pipes. As long as the command at the end of your pipe exits with code 0, Bash will think everything's fine and continue executing as if nothing ever happened. That's not helping. So if you want your script to stop whenever any part of the pipe produces a non-zero exit code, you'll also have to add set-o pipe fail. We're not quite done fixing quirks yet. When I execute this script, the array seems all messed up. Why does that happen? By default, whenever Bash encounters a space, tab, or new line, it'll assume it's a new array element. Not what you would expect with this syntax, right? Well, we can still fix it by modifying the internal field separator, or as his friends call him, IFS. If you set it to split only on new line and tab, it will separate the items in the way you'd expect. Let's talk about functions in Bash. They don't work the way they do in modern programming languages, so if you're used to the return keyword, don't use it in Bash. It has a different meaning than what you might think. You probably want to use echo instead, and then use command substitution to capture the function's standard output. There's another caveat when you're trying to return arrays. Echo won't help you here. The simplest solution is to assign the result of your function to a global variable, which honestly, I feel a little iffy about. Okay, final situation. Find the issue. The string equality operator isn't double equals in Bash. In fact, string equality is single equals, except that it's the amount of white space that determines whether you're doing an assignment or an equality check. If you often work in languages where white space doesn't matter, this will be a habit to watch out for. Ultimately, shell scripts do get the job done, but is it worth the hassle? You've got to remember that Bash's first release came out in the late 80s, with much of its scripting syntax going way back to 1977. Programming has changed a lot since then. New languages brought syntax improvements and new concepts, while some older languages fell into obscurity. Nowadays, for complex scripts, alternatives like Python seem more straightforward. Still, Bash is more widely available than Python is, and writing a good one-liner with it can be really satisfying, so it remains an obvious choice for small tasks. There are even more bash quirks that I couldn't cover here, but if you're so inclined, I've linked to an article that lists a fair amount of them in the description. As always, thanks for watching, see you next time.